All right, y'all. We are looking right now at the topic 11 notes, and we're dealing with some stuff that is what is called radian measure. Now, there's something you probably never really thought about before, but we've always talked about all of our angles in terms of degrees in between 0 and 360. And whenever you're like watching the Winter Olympics a couple of weeks ago, you hear about every rotation being counted as 360 degrees, and when they do two of them, it's 720. When they do three of them, it's 1080 and all that stuff. And you hear about all of this, and you never really think too much about it. But when you give it a little bit of thought, you can really notice that 360 degrees, that is an entirely arbitrary concept that somebody way back in the day when math was being invented, probably in ancient Babylonian society, 360 degrees was just what they came up with. There's no real reason for that to be. And so, what we're going to talk about today is a different measurement for angles. Okay, and that measurement is called radians. Okay, and you can notice that word radian pretty similar to the word radius, right? That word radian and radius is pretty similar to each other. Okay, there's a reason for that. The reason for that is this. Okay, we're going to take that first circle that's on your page, and we're going to draw a radius on it. And we're going to say that radius is length r. Now, if I wanted to use that radius and make an angle inside of this circle, okay, let's say that I made an angle that went through that circle, and this angle theta right here, let's say that we made it to where that angle theta was set up so that this arc around the outside of the circle, this arc right here, was the same length as the radius. So that arc length was also r. If that is the case, then that means that angle, theta, that angle equals 1 radian. Okay? So 1 radian occurs when the length of the radius equals the length of the arc. That's the first two blanks to fill in on your notes. 1 radian occurs when the length of the radius equals the length of the arc. Okay? The next thing we're going to look at is down on the second circle. We know that the circumference equals 2 times pi times the radius. That's what we talked about in yesterday's lesson. The circumference equals 2 times pi times the radius. Well, if that is the case, then that means if we had an arc, like what if we had on this circle, we had an angle, okay, it started right here, and we rotated all the way around, all the way to right there. Now, we know if we're talking about degrees, that rotation was 360 degrees, right? Well, that rotation creates an arc. If we're going an arc all the way around the edge of this circle, that arc length would be equal to the circumference. Okay? And since the circumference is 2 pi r, then that means the number of radians that you had in this rotation, the number of radians was 2 pi radians. That's how many radius lengths you have going around the edge of the circle. So that's how many radians you have in that angle. So if you're talking about a 360 degree rotation, that would be 2 pi radians. And if you do a little bit of simplifying, a little bit of dividing, 180 degrees equals 1 pi radians. Okay? So this is something that you're going to be dealing with a whole lot in pre-cal, and we're just preparing you for that right now. Okay? We're just touching on the basics of converting between it right now, but I wanted to show you where this came from, so that when we talk about degrees and radians, I'm not just making this up. This is a real thing that is directly related to the radius of the circle. Okay, a radian measurement is directly related to what the circle is. Okay, now I want to also point this out. Something very important right here. This number, 2 pi, you got to remember that pi is not a variable. I said this in the previous lesson. I try to emphasize it any time that we're dealing with pi. Pi is not a variable. Pi is a number that is equal to 3.14 approximately. So that means when we talk about 2 pi radians, that is equal to 6.28 radians. When we deal with pi radians, that is equal to 3.14 radians. Okay, so when we talk about 2 pi equals 360 degrees, or 1 pi radians equals 180 degrees, we're talking about a number of radians. Okay, and we're actually going to look at that here on the next slide. You're going to see as we deal with one full rotation equals 360 and one full rotation equals 2 pi, what you can do is make those equal to each other like we just did. And if you simplify that all down, you end up with 1 degree equals pi divided by 180 radians. Okay, and if you take a calculator, you can see that pi divided by 180 is a very, very small number. Pi divided by 180 is 0.0175 approximately. Okay, so 1 degree equals 0.0175 radians. And if you do that conversion the other way, you would get that 1 radian equals 180 divided by pi. So you flip it over. Okay, and if you flip that over and type it in the calculator, 180 divided by pi equals 57.3 approximately. Okay, so 1 radian is about 57.3 degrees. Okay, so what we're going to be doing, the reason we're going through all of this is because we want you to be able to convert in between radians and degrees. Okay, so in order to convert degrees into radians, you multiply times this number right here. You multiply times pi over 180. Now that is not the most complicated thing in the world, y'all. Okay, what we're going to do is we're just going to treat this like any other multiplication. 311 times pi over 180. Now you ask yourself, does it change anything if I say that's 311 over 1? The answer is, of course not. Of course that doesn't change anything. But then you can set it up just as multiplying fractions. Top times top and bottom times bottom. So top times top is going to be 311 times pi. Bottom times bottom is going to be 1 times 180. So 311 pi divided by 180. Okay, what we're going to do is just like we did in the previous lesson. We're going to keep this in terms of pi. Okay, that is a thing that is consistent in a lot of mathematical notation, is that whenever you're dealing with radian measurements, you keep your answer in terms of pi. You do whatever multiplication or division that you need to do with the other numbers. Okay, we're going to go ahead and divide in your calculator. We're going to divide 311 divided by 180. But we're going to leave pi alone. So when we divide 311 by 180, we get 1.728. And then we just have that pi attached to it there at the end. And that's it. Okay, so 311 degrees equals 1.728 times pi is the number of radians. Okay, next is more of the same. Okay, we're multiplying, or we start off with a measurement of 54 degrees. We want to turn that into a radian measurement. So we take that and we say multiply times pi over 180. Okay, you can put that over 1 if it's going to help you. If it's going to help you recognize and keep track of top times top and bottom times bottom. So on top we would have 54 times pi. On bottom we've got 1 times 180. This time we're doing the same exact thing, okay? We've got 54 and 180 as our two numbers. That's what we're going to divide. 54 divided by 180. That, if you simplify the fraction down, it's 3 over 10. Or if you just punch that into the calculator, you've got 0.3 pi. Okay, again, we're leaving the answer in terms of pi. We do all of the other multiplication or division, but we leave pi alone. Okay, our last one is the same thing yet again. 75 times pi over 180. On top, we've got 75 pi. On bottom, we've got 1 times 180. We can simplify that fraction down and give us 5 over 12. So it'd be 5 pi over 12. If you want a decimal answer, that would be 0.417 pi. Again, we're just leaving it in terms of pi. All right, going on to the next set of problems. In order to convert radians into degrees, so this time we're going from radians over to degrees over here. Now we are going to multiply times this number, 180 over pi. It is the reciprocal of what we multiply to go the other direction. So, question D is asking, convert from the measurement of 3 radians to how many degrees? Okay, how many degrees is equivalent to 3 radians is what it's asking. So we take that 3 and we multiply times 180 over pi. Okay, now when you're going in this direction, we do not leave our answer in terms of pi. So this time our answer is not in terms of pi. Okay, so that's going to be equal to 540 over pi. And that's something you can just type right into your calculator. 540 divided by 3.14, we get an approximate answer of 171.89 degrees. So 3 radians is equal to that many degrees. Okay, question E is more of the same thing. We take that 5 pi over 12. It's already in fraction format. So we can just multiply straight across, times 180 divided by pi. Okay, we do 5. On the top, we've got 5 pi times 180. On the bottom, we've got 12 times pi. Y'all notice what happens right here. Look at this. We've got pi on top, and we've got pi on bottom. They cancel each other out completely, and we don't even have to deal with it. Okay, there is no pi in this answer. So that's how we got rid of it. Now all we have left is 5 times 180, which is 900. And on the bottom, all we have is just the 12, no pi. So 900 divided by 12, you can just type that in the calculator to tell you. That's 75 degrees. Okay, so 5 pi over 12 radians equals 75 degrees. Okay, next we're going with negative 2 radians. I know we haven't talked a lot about negative angles, but that is something that can happen. If your angle is measured as negative 2 radians, we can put that over 1. It doesn't change its value, and we multiply times 180 over pi. Okay, that's going to tell us that we're dealing with the equivalent. That'll change us to the equivalent degree measurement. So multiply top times top is negative 360. On bottom, we've just got 1 times pi. And again, we've got something you can type into the calculator exactly as it is. It is negative 114.59 degrees. Okay, so I know a lot of that stuff at the beginning with where did radians come from, that can be kind of confusing. But I think the problems themselves, where you're just converting back and forth, not that difficult, not that crazy, okay? So if you have questions as you're working through the Canvas problems, let me know and we can get this figured out, all right? Y'all have a good day.